início. Obrigado pela vossa presença. Hoje vamos ter aqui temas de bastante atualidade. Um deles tem a ver com a matéria de sustentabilidade. Estamos a falar de resíduos e tudo o que anda à volta disso. O Dr. Teckmeier vai apresentar um sistema inovador de valorização de resíduos e mais alguma coisa. E também temos esta matéria nova ou relativamente nova dos bisfenóis, que já se está a colocar e que vai ser o futuro próximo, não é? Portanto, da TFL, Lopes Ferreira, muito obrigado também pela vossa participação. E vamos dar início. Dr. Teckmeier, thank you for coming. And
I will stand up. Yeah.
Ele vai fazer a apresentação em inglês. Se alguém tiver alguma dúvida, alguma questão, pode colocar para nós traduzimos.
Yeah, I have to speak English, but I understand a little bit of Portuguese and Spanish language, so but I can't speak. Sorry about this. Thank you very much, and I very much appreciate here so much attendance, and thank you, Bruno, for organizing this. And it's the second time that I'm here in this tanning area. My name is Dr. Teckmeier. I'm from TFL now, and I'm leading up a role which is called Business Development and Industry Relations. Industry Relations means that I'm representing TFL here in Leather Naturally, in ZDHC, Leather Working Group, and the Sustainable Leather Foundation. Yeah, I'm in the executive committee here, and in the advisory committee here, and here. And so I believe, and we believe actually, it is extremely important. The leather industry is very much fragmented, and you know, leather as a material is under attack in media from many directions, and we all have to stay together in order to work on a good image and the right story of leather. Yeah? And that's what we try to do here in these NGOs. You know, this is for environmental auditing. Leather Naturally actually should be our voice for clean chemicals. It's the ZDHC and Sustainable Leather Foundation. If you haven't heard about, Google it. Excuse me. And they want to have a dashboard that if a shoe or a bag is in a shop, there is not only the price tag, there is a QR code. You can go with your phone on it, and then you see how the leather was made and where it is made and so on. So that is the idea, consumer promotion. Yeah, if you have a question, whatever, my name at tfl.com is the email address, or it's much easier LinkedIn. If you follow me there, then we can stay in contact. Yeah, I want to talk a little bit about green chemistry, and especially why we should switch to green chemistry and what kind of opportunities we have in upcycling of the byproducts in leather manufacturing. One little slide in the beginning. I'm coming from Lanxess, and since 1.5 years, TFL and Lanxess have formed a new company, the new TFL. Yeah, we were both more or less even in market share worldwide, but we were very complementary. That was very good. Yeah? TFL was very good in BMOS, strong in dyes, fat liquors. Regionally, they were very strong in South Europe, India, Latin America, rest of the world. And Lanxess was very much complementary. Our strength was syntans, waterproof, and finishing, especially automotive finishing. We were the #1 in China, strong in NAFTA, Korea, Thailand. So it was a very good match, these both companies. Yeah? And TFL is very strong in fashion, and we were strong in technical articles like automotive. So we believe together we are even better, and we hope we can provide more service and more technology to the industry. Yeah, sustainability, we all know the word. I mentioned this. Sorry, no Couro. I mentioned this already once. this morning. I was in 2005 in Brazil giving a talk about sustainability, and there was also a room like here, 20, 30, 40 people there, and they thought I'm coming from the moon. They have never heard the term sustainability. That was in 2005. I remember this very, very much. And if we think what happened in the last 15 years in our industry, really we can be all very proud of us. Yeah? That is extremely good. LWG was giving a very big kick on this, but all in all, that's very good. I mean, sustainability was the first time actually defined really here in the 80s, but the kick-off in the Western world was the Club of Rome. I don't know if someone has heard about this. That was the Club of Rome, and a few smart people, and they have made a publication, Limits of Growth. And it hit like a bomb blast in the Western world, because they were the first time that they said the way how we are operating, linear, starting from fossil, ending up with trash, which ends up on a landfill, yeah, is in between we consume something, yeah, but this linear production philosophy is leading to a disaster. Yeah? We need to change this. And they also said oil is limited. Yeah, so that is the limits of growth. That was actually the kickoff to think about. And in the 80s, then the United Nations took it up, and they developed this famous three-pillar module, yeah, ecology, chemistry, and I'm sure you know a little bit. And then in the 90s, it became global. Yeah, and in the early 90s, there was in Rio the first global conference, and then afterwards in Bonn, the United Nations established a department for sustainability. And then in 2000, Kofi Annan, one of my famous politicians, he even said sustainability and prosperity needs to go hand in hand. Yeah, we can't clean up the world if we are not solving the poorness in the world. So that actually was his goal, and we all know the Paris Declaration in 2015, and there these 17 Sustainable Development Goals were established. Yeah, and this should be the Bible for everyone. Yeah? We should, in each kindergarten, in each elementary school, we should teach the people already that this is what we have to work for. This was, let's say, the political thing, but also in the industry, there was a path. Yeah? Responsible care was established from the chemical industry in the 80s, 90s. And, but in this area, this is called harm reduction era. That means the chemical industry was solving the pollution. Yeah, they building wastewater treatment plants, emissions, and so on. So they were working on symptoms, but not on the root cause. You know, and then the next era comes, strategic era. It's called big companies like BASF, Bayer. Excuse me. BASF, Bayer, and also IKEA or so, they all made a department for strategic sustainability, but when it came to profit, they said, okay, sustainability is nice, but we do what profit is going to make for our company. And this is also going to change now. There are more and more companies which really take sustainability as a scope of their company. Big brands already, also forced from the financial industry, and the purpose-driven era, this is an extremely good and changing thing, but even the next era, and that's now the introduction actually to my chart, is already announced, and that is called regenerative era. Regenerative era means that we go away from this linear consumption to circularity, that we use biomass as a main raw material for everything what we do. And this is going to come. This is a mega trend for the next 10 to 15 years. And we in Netherlands, we have a good advantage. We have a good opportunity. Yeah? We are hitting right all the box marks. The boxes what the regenerative era is going to promise and drive. So, very good. What are the 4 elements for us in the leather industry? Circularity, that we recycle as much as possible on byproducts, that we become climate neutral. We also need a lot of energy because we have to dry and so on. And this needs to be climate neutral, also the materials, the chemicals. Biodegradability, it's a big advantage for us compared to all the plastics. I always say you will never find a leather fiber in the stomach of a whale, but you find plastic. If you have a dead body of a whale and you open it up, you find 50, 60, 70 kilos of plastic in the stomach. Leather is not ending up there, it's deteriorating on the way to him. And then, of course, ethical sourcing, that is a special thing for leather. And that we are using the right, the rawhides from the right areas in the world. So, for everything, actually, we have already a solution, upcycling of byproducts and waste, that I'm going to talk about later on. Chemicals, which are based on a renewable origin. Plenty of chemicals are available, and we in the chemical industry, we work more and more to develop this. They have no harm for the environment, and in these NGOs like Leather Working Group, we are working on transparency on the supply chain to make sure that the leather comes from an animal which had a good life and which was not on a deforested Amazon area or whatever. So that's all there. Our chemicals are called POA. At Lanxess we call it ex-biomere, and here I think Bruno can support you in testing and trying them out. That is the last clear intro slide at TFL. We are a chemical provider, so we are offering process and other chemicals. But we want to become now, and that is actually one of the message for me, TFL wants to become a solution provider to the industry. We also want to offer technologies to upcycle, to recycle, and so on, and fleshings, shavings, hairs, and that's get some water. That's what we have changed, or let's say expanded in our strategy of our company. Yeah, we want to be a solution provider and chemistry, chemical provider to the industry. So now still 5 minutes, a few terms and definitions, and renewability, what it is. Yeah, it's biopolymers which are derived out of renewable biomass. And of course these chemicals can be chemically treated and changed, and but the base is still renewable. Then there are a lot of terms with biodegradability and compostability. I don't know if you know the difference. Biodegradability is clear. If it biodegrades by microorganism, enzymes in the nature, plastic can't biodegrade, only physically getting smaller and smaller and smaller, and then it's microplastic, but the plastic is still there. There are no enzymes which can eat up the plastic, but there are enzymes which can eat up the collagen. That is different. And that is biodegradability. Compostability is just that is an STM method to measure biodegradability. It's just a standard. In which days, in how many days, and so on, something has biodegraded. So, from a schematic, what are the best materials, origins, and type of materials in our chemical world? You can put this in a scanner. We have here in the Y scale from a renewable origin, which is good, and from fossil source, which is bad. So you have something which is good, biodegradable, and you have something which is poor biodegradable. So here we have all our nicely vegan stuff. It's called, it's nicely called vegan stuff, but it's actually bad, because it's from a fossil source and it's very, very difficult only to biodegrade. The famous Pampers, I have a grandchild now, and we also do the Pampers at home again. That is 800 years on a landfill when it is degraded. Yeah, it's terrible. No? And polyester PVC is even worse, you know, and that's why I put it in red. Then you have materials which we also sell and which is available. That is here for polycaprolactam and stuff like this. These are polymers which are based on oil, but which can biodegrade because they copy a natural polymer. So there are enzymes and microbes which can biodegrade them, which is already good. You know, if they are ending up somewhere in the environment, they get degraded, although they are based on oil. Then you have the materials like, for example, nitrocellulose. Yeah? It's coming from the nature, yeah? So it's from a renewable origin, but you functionalize this in the chemical industry that the enzymes can't eat it anymore. Yeah? So they are poor in biodegradation. So these both are in yellow, and there are green materials, yeah? And this is our famous collagen. It's coming from the renewable origin, and it is biodegradable, yeah, and that is actually the future, yeah, and also cellulose, acetate, vegetable tanning agents, lecithin oils, and there is a lot of chemicals which we already have, which are based on bio-origin, and so there is already a lot of available, but it's a process, and we are going to work on this. Here's a schematic draw, collagen. These are the days when you biodegrade 100%. Yeah, it's in a few days it is 100% biodegraded. Our chemicals, which I'm going to talk of, is Pure A, X Biomers. Yeah, they already are very good in biodegradation. No? A syntan is pretty poor and a polymer for finishing, polyurethane or acrylic, also it's very poor. You know? So we need to make sure that we get more and more and more chemicals here in this range. So what's the situation today? Leather, yeah, we have between 60 and 80%, depends on the recipe of the leather, is collagen. Fine, it's bio-based, it's biodegradable, but we have quite amount of chemicals, 25 to 40% built in the leather matrixes, you know. We also use some process chemicals, but they are ending up in the wastewater. So if we look at the functional chemicals, yeah, which all the chemical companies, yeah, like TFL, Stahl, Trumpler, Smith & Sohn, Schillen-Seilacher, all the chemical companies, more or less 1/4 of the chemicals which you use in leather are bio-based, and the rest is fossil-based, and some of them are inorganic. And if you look in the segments, finishing, softening, dyeing, retanning, filling, tanning, here, this is the biggest area where we can improve in the chemical side, yeah, to get more green footprint in our leather, yeah, because this is the biggest mass of chemicals, retanning, filling, dyeing, softening, what you incorporate in the leather matrix, in the collagen matrix, and here we need to make sure that we get more and more and more based on bios. Softening, of course, lecithin, fat liquors are already a lot of bio-based. Dyes is different, but here, this is the target area where we would like to offer you change. Yeah, why? It's very simple. If it comes from oil, yeah, and you have a material where the chemicals are incorporated or made out of, if you afterwards burn this, it's additional CO2 in the atmosphere. A leather comes out of the hide of a cow. The cow eats grass or other natural products, and you see this is made out of CO2. So the entire cow is actually made out of CO2 coming from the air, and whatever goes away, even the methane, yeah, is actually ending up again as CO2 in the atmosphere. So that's neutral. That's neutral to our planet, and that's where we have to go to. Yeah? And that's why I believe in this law of conversion of mass. We in the leather industry, we have a huge advantage in this regenerative era I mentioned, which is going to come. Yeah, there's a nice method to measure how much carbon comes out of in a leather or in the plastic, comes out of this loop and knot. That is called the C14 method. I will not go into detail right now, but I gave Bruno a very nice presentation about this, or if you are interested, you can share this, and then you can read it if you don't know this. Yeah, there you can measure how much of the carbon in the leather is bio-based and how much carbon comes from fossil. Good. Yeah, that's the way to go. Sustainability. One little thing is also interesting, because I look at this. We say the biomass. That is our pool of raw materials where we have to think of, you know. And the biomass in our planet, this is the quantities, plants, bacteria, a lot, fungi, and here this little piece, this is animals, protein, animals. And if you look, this little piece, if you make it big, the majority, 2/3 of it, are insects, worms, spider, jellyfish. Fish is a lot of biomass from this portion, livestock, and here we are, very small. Yeah, that's the amount of the bodies of all humans, all 8 billion humans. It's so tiny, it's so Mickey Mouse what we add as a biomass. But yes, if we want to use the biomass as raw material, then we have to use this one, and the majority is cellulose, lignin, wood, hemicellulose, and this is starch, potatoes, and so on. So, if we translate this into pictures, these are the 6 sources of materials which we should maximize in our chemistry, because these are all renewable materials, and all products which we make out of them are so-called bio-based products. Vegetable, animal oil, talk about animal proteins, hydrolyzed, vegetable proteins like soya, cellulose, lignin from woods, amylose, starch, sugar. It's a different chemistry for the chemists. It's clear. That is actually the stuff which we can digest in our stomach. Cellulose we can't digest, only the animal can do. And then of course we have enzymes which we use in processes. So these are the sources, we should focus on it, and as much as we can use this, that should be the priority. And we have done quite a bit already, but we are working on this, of course. And in the wet end we have fat liquors, which are based on animals. We have fillers, the Biomare Pure A product range, instead of syntans and resins, what you can use in retanning, which are based on what we have: vegetable protein, soya fillers, we have cellulose fillers, Pure A, and we have fillers on this. So this is already a big range for retannage. And we also have some softening chemicals, which are 100% based on biomass, and also in finishing oil, waxes, casein wire, top coat, bio-PUs. So we need still some oil and some inorganic stuff for these products, but we try, of course, to minimize this. And I'm going very quickly over these charts. We have the bio-based content, we have a calculation method, whenever you make a recipe and you have products from us, we have the bio content, and then you can calculate actually how much of your recipe.
You want me to explain better in Portuguese?
Huh?
You want me to explain it in Portuguese?
Yeah, if you want, yeah.
Nós a TFL já tem todos os produtos da gama estudados com a quantidade de bio de cada um, ou seja, nós quando estamos a formular, sabemos a quantidade de matéria renovável que cada produto tem, e ao aplicarmos esses produtos na pele, ao chegarmos ao fim da receita, da fórmula, sabemos que aquela pele tem 40, 50, 60, depende dos produtos selecionados para o fim. Podemos dizer que a partir dos 50, from the non-says it's from 50% it's bio. Ou seja, a partir dos 50% já é considerado biodegradável. Neste momento nós podemos quantificar isso em termos de formulação, ou seja, aplicando os produtos certos, utilizando a informação que...
Portanto, há uma aplicação, uma calculadora?
Sim, nós temos, internamente, temos uma calculadora onde temos os produtos todos discriminados e cada produto já tem calculado a quantidade bio.
Consegue-se calcular o
total
bio
do total daquilo que estamos a aplicar na pele.
Okay.
Yeah. So we have quite a number of products already which have a high content of biopolymer mass. These are the old traditional chemicals, yeah, and that's what actually he was going to say. If you have now an automotive recipe wet end, you know, this is a standard formula traditionally, and this is a new one, and then it calculates automatically, this program, what is the bio content of this chemical recipe. No, these are only the chemicals, not the collagen, yeah. And you can see we can come up already with close to 60% for a good leather with automotive standard quality. And in finishing, it's the same. And here, of course, it is very low currently, but we have already products to make automotive finishings, and that you also come to 50% of bio-based. So we are in the process. Yeah, we continue to work on this. But we have already quite some achievements, and if you want to make articles which are maximum bio-based, this is a very good tool and playground to do this. Okay, now I'm coming to this topic, recycling and upcycling. Yeah, that is a process topic. Yeah, I don't know if you know this 3R principle: reduction, reuse, recycling. That is from the United Nations. Long time ago, in the 80s developed, yeah? That the priorities, whatever you do in your process, first think on avoidance. Whatever you can avoid, it's good, yeah? So if you use a fresh hide instead of a salted hide, it's always better, yeah? Even if you have now processes to retain the salt and to clean it and so on, you know, but it's even better to avoid it, you know? Then reduction, yeah, that you use chemicals with a high exhaustion, yeah, or that you use enzymes in the beam house, yeah, because you can minimize the amount of process chemicals with enzyme technology and so on. Then, if this is not possible, then you should think on reuse and recycling, yeah, and that's what I'm going to talk about now. The retanning chemistry I mentioned in the beginning is the chemistry which it's a chemistry which has the biggest mass. Yes, you need to make the leather stiff, you need to make the leather soft, you need to make the leather colorful and so on. These are all chemicals which we incorporate in the collagen matrix, and therefore the biggest volume are retanning chemicals. And here we said, let's think about some kind of chemicals which are based on, here this is cellulose, this is a protein, these are the two biopolymers, yeah, and then we do a functionalization with acrylic acid, and then we get molecules, and these molecules can be used as retanning chemicals for many, many applications. On front, I would say roughly at least 1/3 of your retanning chemicals in recipes can be switched to bio-based chemicals. Not all, no? It's not the wonder chemical, but there is already a significant amount of chemicals which you can switch, and they have good footprint, quality and safety, and of course the ecological footprint. So, and yes, that's a circularity. Those products are based, for example, on shavings. Yeah, I come to this a little bit more in detail. So a tanner, generates shavings, pack the shavings, transport the shavings to our company. We are going to produce it currently only in China, in our production plant, where we are introducing our new facility from our perspective, from Lanxess perspective, the new TFL facility in France. So we can do this there, and we are just in process to produce it there as well, that you can have them available here in Europe as well. So we are producing those chemicals, then either we send you this as a liquid or we spray dry. Spray drying a syntan, a powder syntan, costs 1.5 megawatt per ton of product. Yeah? It's a lot of footprint, carbon footprint, what you get if you buy a syntan as a powder instead of a liquid. Yeah? So if you want to optimize your carbon footprint, to switch from powder products to liquid products, it's one of the easiest and fastest way to reduce this. Yeah, but for long stabilities, if you transport a product at the end of the world to New Zealand or whatever, of course it's much easier and cheaper to transport it as a powder. So then afterwards we transport it back to the tannery. So, and there is a lot of cost involved. Yeah, here we talk about just the packaging of the shavings, 5 cents per kilo. Then transport this to us again, 5 to 10 cents per kilo. Here to pack it into a drum or into an IBC, 5 to 10 cents per kilogram, ship it back to you. So nearly 50% of our cost, which we deliver as an ex-biomer or pure A, are just transportation and handling. It's nonsense. It doesn't add any value to a product, yeah, to the actives, to the performance of a product. It's just wasted money and energy and material, and this we thought could be changed, you know. And instead of bringing products back and forth, why not making a small chemical unit and placing this, for example, here in your area, and then you can bring the shavings here, and we produce here the products based on those byproducts. Yeah. This was the idea, and we have teamed up with a company in Germany, Heller, and with an engineering department which made these container-produced production units, and that was still at Lanxess, and we got quite some government funds in Germany to test this, because they said it's a chemical company to go. Yeah, that is a paradigm shift in chemical thinking. Yeah, away from these huge chemical plants, back to decentralized production on site in tanneries or in tannery zones. And yeah, we have made this project and we finished this, and actually we have proven that this might be a possibility to do. And that's why I'm here now to promoting this. So that was our production unit, 2 40-feet containers. Yeah, it's an on-site solution, on-site, on your site, to recycle and upcycle the byproducts into either beam house or retanning chemicals. And it's a modular production plant. That means the idea is that we engineer and construct the whole plant, and we ship it on a container in the tannery and plug and produce. It's ready to go. No? And it's a complete new business model. Yeah? Then we are not selling chemicals anymore. We are enabling actually the tanneries or the tannery zoo to produce its own chemicals out of its own byproducts. Yeah? So that is very much interesting, and of course we have an IP on this, and then we would get some kind of an income on a license. And yeah, that is the idea, what we are going to promote. Here you see when we installed it at Heller, yeah, that was just half a day. It came with a crane, and then we plugged it in, and next day we were able to operate this pilot plant. You know? That's how it looks like. You enter the shavings into such kind of a bucket, and then there is a pipe chain conveyor. There is a chain which goes around, and in this chain there are some kind of what do you say? Yeah, right. And you move it. You move the shavings are very difficult to transport. Yeah, if you have a spiral it doesn't work. They are compressing, and it's not so easy. And then we found out this pipe chain conveyor, and it was very good. We can 10 cubic meters per hour. We can dose then into a vessel. So it is very 10 cubic meters per hour. Yeah. So it's quite good. So a little bit, very little bit to the chemistry. This ex-biomer chemistry, or now we call it pure chemistry.
Ou wet white, o que seja, pode ser qualquer vegetal, sim, também.
Yeah, it could be wet white or wet blue. Yeah, right. I come to this. Yeah, and the chemistry is a two-step process. In the first step, we use starch and shavings. Yeah, this is our main raw material. We hydrolyze them. That means we make it liquid. Yeah, we put the shavings into a vessel, sodium hydroxide and some enzymes, and we heat it up, and then the polymer becomes smaller and smaller and smaller and smaller, and all of a sudden it is so small that it is liquid. Yeah, so then you have a solution. And these solutions, the same we do with starch, then we have the two solutions. These two solutions we mix together. It sounds very easy, but the tricky thing is that we have the right molecular weight distribution, yeah? That it fits in the fibers of the collagen. Yeah? So it's, but this we have learned, and we are able to manage this. So you have the right solutions and the molecular distribution of the particles. And then we add a functional polymer. That means acrylic acid. It is mainly, yeah, we add acrylic acid and a chain reaction starter. And then comes an exothermic polymer reaction. And these core molecules are polymerizing together with the acrylic acid. And what we do, this picture is a corona molecule. I took it out of the internet, but that's exactly how we believe our ex-biomer molecules are looking like. We have the core, which is out of the protein and the starch, and the acrylic acid is doing some arms on it, you know. And depending on how much acrylic acid we put in, arms are longer, smaller, yeah. And these arms, actually, they are the functionalities that you have a good exhaustion. Yeah, in the leather, that it is fixed in the leather, and also that it is fixed on the right parts in the leather, and which is even more important, they are also boosting up the light fastness of this chemistry. Normally, bio-based chemicals have very good yellowing and very poor in light fastness and so on, yeah, because it's a natural product. But due to this chemical modification, the light fastness and all these properties are improving. So this ex-biomer chemistry is not a simple protein filler. Yeah? It's really a synthetic chemical, but based on a natural origin. Yeah, that is again the shavings, starch, and also some acrylic acid, and we make the bio-based product out. We now have a range of different types of products, and for example, our main product, a resin type, you know, if we have a high amount of shavings, a small amount of starch, and also a little bit of monomer. Yeah, so this product is a liquid then. It has 40% solid content, roughly, 40%. And from this solid content, nearly 90% are shavings, 10% or 5% is starch, and 5% is acrylic acid. So this is the product with the best recycling power. Then we have other products. They are more polyacrylic type of products, like a Locutan 1084 or something like this, and they have smaller amounts of hydrolysate. And then we have also a third product, which is very much of interest, because these fillers are fillers; they do not tan. Yeah, that is why the usage is limited. Yeah, you need to have tanning power in retanning as well. Yeah, not only filling. And that's why but we were able to make out of the biomass a tanning power molecule mixing with vetch. This you can do also in a recipe that didn't add benefits, but we found out something. If we take a sulfone-based tanning agent, retanning agent, and as an intermediate in the second step, we polymerize this with urea and with formaldehyde, and before this step in our synthesis we added here, we can incorporate this sulfone intermediate into this process as well, and then we have even tanning power. So that's a hybrid between a syntan and a biopolymer, and at least it contains 50% bio-based products compared to a normal syntan, which is 0% bio-based. No? It's a step in the right direction. Yeah, this is the plant again, and based on this pilot plant, the pilot plant is only 1 cubic meter vessel. Yeah? So it's too small for an economic case. Yeah? So for an economic case, we have to have a bigger vessel. So that is a plan which we are going to implement hopefully soon somewhere. We are in process to finish the engineering, and this plant then is also based in 20 feet containers, and you can use chrome shavings as well as wet white shavings. The easier thing is wet white shavings. With the chrome shavings, if you hydrolyze them, then the chrome precipitate as chrome hydroxide in the bottom. Yeah? But first we said, oh, now we need to separate this and to dechrome the whole hydrolysis. And then we said, forget about it. Let's leave it in. And that's what we did. We did then the second polymerization step with acrylic acid. We kept the chrome as a chrome hydroxide inside, neutralized, and if you add this slurry, this is a slurry then of course, yeah, you need to stir it up before using, but this chrome you can add in the retanning drum, and it's taken up by the leather and even has positive applications, because it adds up, it has a better exhaustion because you have a more cationic retanning, yeah, and for the dye stuffs and so on. So you can use either, that is actually the answer, chrome shavings or wet white shaving, both is in principle possible. No? Of course you can't use this chrome containing X biomer for a wet white recipe. That's logical. No? You have to use it then for a wet glue article. Yeah, if we have a plant like this, yeah, in a tannery, yeah, we have an 8 cubic meter batch tank, and if we do 1 batch per day, that is roughly, it takes 8 hours, this whole synthesis, times 200, 8 times 200, it's roughly 200 days in a year, 1,600 tons capacity this plant, this chemical plant would have, you know, and yeah. You need to, depending on the product, you need between 1 and 4 tons of shavings for 1 batch. And yeah, there is no wastewater, there is no air emission. Everything what you put into the vessel you use afterwards in the retanning drum. That's a good thing. Yeah, that's why we even thought it's a process which we can apply in a tannery or in a tannery zone. Of course you need some energy and steam and some chemicals beside. So the plan is that we have the chemicals, that we provide them in IDCs, yeah, and they are connected directly to the plant, and then you are running in a process control room your process, yeah, and step by step the reaction goes automatically, and in an ideal case it runs without any, you just have to fill the shavings in the beginning, push a button, and then everything works. I always said like a coffee machine, you know, where you enter the beads and so on. That's how it should work, you know. And then you can make out of your byproducts, the shavings, your chemicals you need in retanning. That was the idea, or is the idea. So, like always, nice ideas also need to have an economic case, yeah. And this plant, it's an investment of 1.5 million euros, roughly. Yeah, it's quite a bit. Then you need a person who is running this, and you need energy and so on. So you have cost, yeah? You have fixed costs and you have variable costs. No? And of course, if you only produce 500 tons per annum of this liquid, yeah, then your overall costs are higher than if you would buy a similar product in the market, from Trumper or from TFL or wherever. Yeah? So this makes sense, and the break even is round about at 1,000 tons of liquid expiry. Yeah? And this has 40% solid content. Yeah? So if you compare this with the powder syntan, yeah, it's 400 tons of equivalent powder syntan compared to this expiromer. And if you can use more than 1,000 and produce 1,100, 12, then it starts to becoming even economically advantage or better, cheaper for you to produce your stuff by yourself instead of buying the chemicals outside. Yeah, these are the numbers. We have teamed up with Hüni. Hüni is now our engineering partner. They have all the drawings and the engineering, and working right now on a detailed engineering. Basic engineering is ready, and the idea is then that we make a contract with a tannery or with a tannery zoo, I don't know, you know. And a tannery also can do some retanning chemicals together with another tannery. Yeah, you can team up on. Yeah, that's something which needs to be investigated. One thing I also forgot to mention, and then here, this hydrolysid, yeah, is also actually a ready material for using as fertilizer. If it is a non-chrome, yeah, if it is wet white based shavings, yeah. These shavings, they contain 4 to 5 to 6, depending on the process, % of nitrogen, and this can be sold to the agriculture industry as fertilizer. So if you have, let's say, 10 tons of shaving every day in a big tannery, yeah, 1/3 you can convert into expiromer and use internally as your retanning chemicals, and 2/3 you can convert into fertilizer and sell it outside if you have the license and the partner. And here that is what we said as a solution provider. We want to make the contacts, then we would purchase this hydrolysid and we would sell it as a fertilizer, TFL. Yeah? That is a business model what we would like to have, and yeah, the whole thing should be a win-win situation, but a solution, an environmental solution to the industry. Yeah, this is a topic, recycling. And then also another topic which is very, very much shorter. This is upcycling. Recycling means that you recycle it, and upcycling means that you generate value out of it and sell it to somewhere else. Yeah, I switch these charts, and this is the solution which is in the industry. Yeah, there are several examples in the industry which are using this technology, from Floodweg. Yeah, that is a solution for the flashings and for the flashings. You have to grind it, you have to heat it up, and then you can separate it into fat, into a liquid phase, and into solids. And these solids we also plan as a TFL, and this fat to actually then to purchase from the tannery or from the tannery zoo or wherever is going to do this, and then we can convert this in our chemical company to something even more valuable and sell it in the cosmetic industry, in the biodiesel industry, or somewhere else. And also the briefs here, the solids, which are proteins, can be worked up. And this is also something we believe we can offer concepts to work them up and to sell it, for example, also in the agriculture industry. Yeah. This is the idea of this upcycling of flashings. And I mean, the energy, you know, if you have one height roughly has 15 kg of flashings, which you take away. 10% of these 15 kg is fat, pure tallow. If you convert this fat into biodiesel, yeah, then you get, if you have 15 kg per height, you have 1.5 kg of fat. It results roundabout in 1.3 kg of biodiesel. Biodiesel has 10 kilowatt hours per kilo. So we generate 15 kilowatt hours out of the flashings from one single height. Think about it. If you produce 1,000 heights a day or 20,000 heights a day, how much energy is in this? And I mean, today in newspapers and TV, energy is the discussion. Yeah? I calculated up the leather industry with 200 million heights. It's a nuclear power station. The energy of a complete nuclear power station, what a lot of tanners just pouring away and not using as an energy source. I know there are a lot of examples already, but the majority, to be honest, in India, in Pakistan, or wherever, and it's not, they are not using this as energy power. Yeah? And this, I believe, it's a huge opportunity for the leather industry. It's fantastic, you know? Yeah. So, and that's something we want to further evaluate and also offer to the industry. Yeah, now I'm coming to the end of my presentation. It's just my vision, you know, that the tannery is not only a leather manufacturing company, it's a protein company, you know, and leather is one of the products, yeah, the main product, of course, yeah, but quantity-wise, the leather is only 25% of that, yeah. If he buys 10 tons of wet salted hide, he is selling 2.5 tons as leather, the tanner. Yeah? And afterwards you do the cutting, yeah, and it's again 50%, 60%, 70% cutting yield, yeah, it's again a lot which is off. So we all need to think about solutions that we can recycle and upcycle as much as possible. That is the name of the game for the next 10 or 15 years, I can tell you. And if the leather industry is capable to manage this, then we are a sexy product in this regenerative era. Yeah, that is the example. Yeah, if you would invent leather today, that would be the perfect material. Yeah, and here I made a chart with all these possibilities to upcycle. Yeah. The in situ, the hydrolysis, yeah, can go to fertilizer, then we can do it as a retanning agent and recycle it. Then we have the scraps. There are also solutions out that you can do something with this. With the fat, you can do it in soap and biodiesel and cosmetic applications. So there is a lot of opportunities out, and this systematically to implement. I think that is one of the big jobs for the leather industry in the next 10 years. And if you do a mass balance, yeah, the 10 tons and the 1.5 pieces which go away in a handbag or in a shoe, yeah, all the other stuff, if it is used, I mean, you also have to do your life cycle assessment and your carbon footprint, yeah, on your articles, yeah. So. And the big problem for the leather industry that we have a big backpack of CO2 from the farming industry and from the chemical industry and so on, you know. But if you say, I get this backpack from the farming industry as a carbon footprint, and I use 85% for other application, then only 15% of this carbon footprint goes into your leather article. Yeah? Also from this perspective, not only from an environmental perspective, also for this marketing perspective, for carbon footprint and so on, it is a very, very interesting approach. Yeah? And you can minimize your carbon footprint of a leather article significantly and have a good selling story. If you can demonstrate that all the other byproducts are somehow used. Yeah? Yeah, this is my message, yeah, and yeah. Thank you very much.
Algumas questões que tenham para colocar?
Se querem guardar para o final, o tema que vem a seguir é diferente deste, não é? Portanto,
As I said, you can mail questions to me, yeah, and that is I'm very happy to answer everything.
One question.
Yes.
We have some tanneries that work specifically in veg tanning.
Yes.
This for this kind of flashings or for this kind of scratch.
Also works. We also have, yeah, we tried out veg tanning from Santa Giorgio. We got veg tan shavings, and it also works. Actually, even better, because then you have still a little bit tanning power, no? in these liquids. Yeah, but not much. A little bit of tanning power. So veg tan is also possible. Yeah, if there is any question comes up afterwards, yeah, send me a mail and.
Ou se alguém quiser colocar em português,
Sim.
também se traduz, que é mais fácil. Okay.
Good.
Thank you.
Can I take the cake?
Yeah. Sorry, it was mine.
No, okay.
Later on, we have the wine.
Vamos começar? Então, primeiro agradecer a vossa presença. É sempre complicado sair ao meio de uma tarde de trabalho e agradecer por esse aspecto. Bom, queria-vos falar sobre um dos temas que está muito em voga agora, que são os bisfenóis, ou seja, as restrições que estão a ser colocadas, já estão a ser colocadas na produção da pele, nomeadamente com a utilização de alguns produtos que contêm esta substância. A TFL já está em campo a tentar minimizar a utilização de matérias-primas que contenham este tipo de material, e já temos uma linha desenvolvida de produtos com baixo conteúdo, que nos permite trabalhar todos os artigos, praticamente todos os artigos, com a mesma performance que tínhamos nos produtos anteriores. Os produtos anteriores continuam em circulação ao mesmo, porque o que nos diz a lei é que este ano não há restrição. O ano que vem, a partir de 2024, temos um período de adaptação de 4 anos em que podemos trabalhar abaixo até 500 mg por quilo de bisfenol, ou seja, 500 ppm de bisfenol na pele, e a partir de 2030 ainda está a ser regulamentado a quantidade que se poderá usar. Isto é um tema ainda muito precoce, não é? Ainda não existe, a norma ainda está em estudo, está em desenvolvimento. Mais 9 meses vamos esperar, sim, estão definidos, foi pedido um período, um alongamento de 9 meses, mas o problema vai existir. Nós já estamos a trabalhar na solução para esse problema. Vou-vos dar depois a seguir um folheto, e já temos já uma linha de produtos com baixo conteúdo, todos vão ser lançados com menos de 500 ppm, ou seja, no produto, não estou a falar na pele, que poderemos utilizar calculando as restrições de cada cliente, porque há outra coisa que nós temos de ter atenção, apesar de não estar ainda regulado, algumas marcas já o estão a colocar nos cadernos de encargos. E é nisso que nós queremos entrar. Porque a cada produto desta linha com baixo conteúdo de bisfenol, nós já temos quantificado a percentagem de bisfenol que contém. E só vamos lançar para o mercado se for abaixo daquela percentagem. Ou seja, o que vai nos permitir trabalhar e calcular a quantidade que existe em cada artigo final, ou seja, na pele mesmo. Não estamos a falar no produto, estamos a falar na pele, porque a restrição é para a pele, não é para os produtos. Por exemplo, na versão antiga destes produtos, nós vamos aqui à ficha de dados de segurança e ele vem identificado. Está identificado ali como contendo. São todos os produtos, praticamente todos os produtos sintéticos, os sintéticos de substituição, todos contêm. Uns mais, outros menos. E nós estamos a trabalhar numa linha de produtos já com quantidades bastante reduzidas e neste espaço de tempo até as regras saírem definitivas, vamos de certeza chegar a produtos que sejam, não digo completamente, mas muito provavelmente vamos chegar para cumprir os cadernos de encargo que vos vão pedir também. Ou seja, isto é uma fase de transição, estamos a trabalhar nisso, somos a ser pioneiros nesse campo. Vou-vos mostrar agora a ficha de segurança do produto equivalente ao que vos apresentei anteriormente, e se vocês virem, já não aparece na parte já não vem representado nada de bisfenol, ou seja, aqui estamos a trabalhar completamente livres de bisfenol. Também está na ficha técnica desta gama, para ajudar no cálculo, nós estamos a identificar o conteúdo, ou seja, quando estamos a formular, imaginemos, temos um cliente que nos está a requerir abaixo dos 200 ppm, nós já sabemos, temos 0.1, sabemos até onde é que podemos ir usando este produto no recurtume, até que porcentagem que podemos usar para chegar ao nosso artigo, complementando com outros produtos, usando mais, usando menos, para chegar ao nível que pretendemos. Ou seja, a informação está toda na ficha técnica, está toda na ficha de segurança, é usá-la. Estamos neste momento, as pessoas estão um pouco assustadas com todo este tema, estamos a ter muita gente a pedir-nos, mas isto tem bisfenol, quanto é que tem? Ou seja, as coisas são tão precoces, nós neste momento, há muitos produtos que ainda nem sequer conseguimos dizer, ou seja, nós já temos muitos quantificados, mas, além disso, é muito difícil estarmos a comprometer-nos com determinadas coisas, porque não existe uma lei. Mas, como queremos estar um pouco à frente, estamos a lançar uma linha que nos vai permitir estar já dentro das restrições que algumas marcas e alguns grupos já estão a pedir atualmente. Isso eu gostava de passar um bocado mais para a parte palpável da coisa. Nós fizemos um estudo usando já cada um destes produtos, temos peles feitas e convidávamos a ver o comportamento de cada produto. Temos também já artigos feitos, artigos que toda a gente produz, são artigos clássicos, temos flotas, temos notebooks hidrofogados, temos napas, temos wet white também. Então aqui tudo gostava de que vocês se aproximassem, vissem e assim explicava-vos melhor a mexer na pele, que é isso que nós fazemos melhor.
Mas é agora?
Agora sim.
Agora?
Tá, é fácil.
Se quiserem ver as peles fabricadas no lugar e perceberem qual é, digamos, o tipo de propriedades que as peles ficam com esta gama de artigos, façam favor. Podemos abrir as peles. Ah, bravo. Estas daqui. Normal.
Já fez com isso.
How many plants have you already?
Nothing. We have this pilot plant, and we are just promoting this.
You have one
Fun?
already one.
We have a pilot plant with a 1 cubic meter, but in these 8 cubic meters we are still in the detailed engineering, and we are just offering this, and we are in discussion with someone in Italy, in Turkey, in Egypt, and
One question that Because we have representatives of a big double face wool skins with wool. They are asking if this works with wool leather. We have the pieces, scraps of leather, of chrome leather, for example, or wet white leather, but with wool.
With hair on.
Hair on, yes.
Yeah.
This works with that kind of residues also.
I mean, hairs you can hydrolyze. We haven't done it, you know.
Okay.
But hairs you can hydrolyze as well.
Yes. Yes. But you don't know if this system can work also with that kind of trimmings or.
We need to test, but it should work. I don't know a reason why it shouldn't work, you know?
They are putting the question if the wool, the hair can be an obstacle or...
No, the hairs need to be dissolved, you know?
Okay.
The only thing which is, I don't know, if the hairs are... if you work with hair-on process, yeah, then you make the hairs resistant against sulfide and so on, you know. I do not know the conditions in order to dissolve the hairs. You know? That's something we need to figure out. But normally, if we take hairs, you know, from hair saving, yeah, we have hydrolyzed this already, and it's not a problem. It's not a problem. You know? The thing is, you have the pigments from the hairs. You know, this is something which could be a problem.
But if there is the pigmentation of the hairs,
if you have white wool, then you don't have a problem. But if you have dark, brown and black, then you have the pigments in, you know, and this they are remaining, you know, and but also maybe we can destroy this chromophore. And is it a problem to get rid of the trimmings from hair? Is it a problem to get rid of the trimmings?
Think about the rest of the leather that are cutted, but in the state of raw state.
Yeah.
Because we are dealing with wool, and we also have a lot of salt, you know, and we were wondering if there was the possibility of...
Yeah, how much do you have? How many tons per annum per year?
Because
1,000 tons or 100 tons or?
Because when the skins are in salted state, they do a lot of trimmings before, and that's the trimmings they are talking about. If there is
those types of trimmings, salt.
Yeah, okay. I don't see a problem with this. You know that you can dissolve them as well.
We have a lot of.
Yeah, but what is a lot? What is a lot? Are this 1,000 tons per year? Wow.
And we were just wondering if it would work.
And right now you don't know what to do with it.
No, we right now we send it to the. I don't even know where we. It's not the bush.
sending to the landfill directly.
Yeah, but I mean, at least what you can do is, if you hydrolyze this, you know, you can sell it as a fertilizer. Yeah. Yes. You get.
But as you just mentioned, trimming and shaving from the. We were wondering if it would be possible to do it at this early stage.
Of course, yeah.
You were talking about the pigment of the wood.
The wood, yes, the pigment of the wood.
Yeah, I don't know if this is
Because sometimes there's
dark brown and dark, yeah. So you would, a pigment is a pigment, you know, it doesn't dissolve and it's not so easy to destroy. No?
Would be a problem.
I don't know if you put a brown pigment as a fertilizer
There is a problem with that, I think.
you don't think, or you think?
No, I think it's not a problem.
No, me either for this application because it's natural anyhow, and and if you do only this first step, you know, in a reactor, the hydrolysis, then it is much less sophisticated. So the investment will.